Hi students, I hope you understood in the last class what we have discussed, how to find the zeros of a quadratic polynomial, and if the zeros are given or the sum of the zeros and product of the zeros are given, how to find a quadratic polynomial, and by using the geometrical representation like from the graph, how to identify how many zeros are there for the given geometric representation. So today we are going to discuss another topic, that is, if a given polynomial is a cubic polynomial, if a given polynomial is a cubic polynomial, then cubic polynomial means then the highest power of that variable will be 3. That means degree of the cubic polynomial is 3. Then if degree is 3, then it will have 3 zeros. So verifying the relationship between the zeros and the coefficients of a cubic polynomial, that we are going to learn today. So cubic polynomial means the general form of a cubic polynomial, that is, we are talking about cubic polynomial. So in this, the general form of a cubic polynomial, that is ax cube plus bx square plus cx plus d, where a is not equal to 0. If a is equal to 0, what will happen? If a is 0, then it will become a quadratic polynomial, because this term will be 0, then x square will be there. Square means again it is a quadratic polynomial. That's the reason a should not be equal to 0. This is a cubic polynomial. Cubic polynomial degree is 3, so it will have 3 zeros. Let 3 zeros are alpha, beta, gamma. 3 zeros. If it is a quadratic polynomial, we took 2 zeros, that is alpha and beta. Now cubic polynomial, if it is a quadratic polynomial, 2 zeros, alpha and beta. Now cubic polynomial, one more zero will be added, that is alpha, beta, gamma. So if alpha, beta and gamma are the zeros, alpha, beta and gamma are 3 zeros of a cubic polynomial, ax cube plus bx square plus cx plus d, where a is not equal to 0, then the relationship between the zeros and the coefficients will be like this, that is alpha plus beta plus gamma is equals to, observe it carefully, alpha plus beta plus gamma is equals to minus b by a, alpha plus beta plus gamma, these are the zeros, alpha, beta, gamma are the zeros, we are adding, that's the reason sum of the zeros. So sum of the zeros is equals to, observe it here, minus b by a. What is actually b? B is the coefficient of x square. So minus coefficient of x square by a value, the coefficient of x cube. Sum of the zeros is equals to alpha plus beta plus gamma is equals to minus b by a. Now that in words you can write as sum of the zeros is equals to minus coefficient of x square by coefficient of x cube. Now alpha into beta into gamma is equals to, alpha into beta into gamma is equals to product of the zeros, that is minus d by a minus d by a minus d by a. So in words we can say product of zeros, which is equals to, you see now, minus d by a, d is what? The coefficient, constant term. D is what? The constant term. So minus constant term by a is what? The coefficient of x cube. So coefficient of x cube. A is the coefficient of x cube. This is product of the zeros. Inverse. Alpha plus beta plus gamma. Sum of the zeros is minus b by a, where we can write as minus coefficient of x square by the coefficient of x cube, and product of the zeros alpha into beta into gamma is equals to minus d by a, where minus constant term, d is a constant, so constant term by coefficient of x cube. Still we have one more, because three zeros are there, that is sum of the zeros product, sum of the zeros, that is alpha plus beta plus gamma, and alpha into beta into gamma is product of the zeros, and we have one more, that is the third one. First see this, I hope you understood. Now we'll go to the third one. Now we see the third one. First we saw alpha plus beta plus gamma, then alpha into beta into gamma. Now the third one, alpha into beta plus beta into gamma plus gamma into alpha. Observe it. Alpha into beta plus beta into gamma plus gamma into alpha, which is equals to c by a. Now in words, what can you write this one? Sum of the products of zeros taken two at a time. Taken two at a time. Observe it. Alpha into beta, that means 2. We are multiplying, plus beta into gamma, multiplying, plus gamma into alpha, again multiplying. Sum of the products of zeros taken two at a time. Every time we are taking two zeros. Here 2 zeros and here 2 zeros, here 2 zeros. Zeros are nothing but alpha, beta, gamma. Alpha into beta plus beta into gamma plus gamma into alpha, which is equals to c by a. So in the polynomial ax cube plus bx square plus cx plus d, what is c value? Ax cube plus bx square plus cx. So c is nothing but the coefficient of x. Coefficient of x by, here coefficient of a is coefficient of x cube. Coefficient of x cube. Observe it. Coefficient of x cube. This is coefficient of x and coefficient of x cube. C, coefficient of x, a is coefficient of x cube. Sum of the products of zeros taken two at a time is equals to the coefficient of x by coefficient of x cube. This is the relation between zeros and the coefficients of a cubic polynomial. 3 we saw zeros, relation between the zeros and the coefficients of a cubic polynomial. We see one example based on this. Now we see one example based on if three zeros are given and cubic polynomial. See here we have an example. Verify whether 2, 1, 1 are the zeros of a cubic polynomial x cube minus 4x square plus 5x minus 2. If they are zeros, then verify the relationship between the zeros and the coefficients of it. He gave the question, verify whether 2, 1, 1 are the zeros of a cubic polynomial. If they are the zeros, then we have to verify the relationship between the zeros and the coefficients. So first we have to verify that whether they are zeros or not for the given cubic polynomial. Afterwards, if they are zeros, then we have to continue with verification of the zeros and the coefficients. So here, let p of x, the given cubic polynomial we are assuming as p of x. Given polynomial we are assuming as p of x. So let p of x p of x is equals to x cube minus 4x square plus 5x plus 1. So how to verify whether it is a zero of the polynomial or not? By substituting in place of x each time one value. First you have to substitute 2, then you have to substitute 1, because these two values are 1 and 1, both are same, the zeros are equal. So if one time if you get 0, then no need to substitute another time. So x cube minus 4x square plus 5x plus 1. We are putting the value of x first to 2. So let p of 2 is equals to 2 cube minus 4 into 2 square plus 5 into 2 plus 1, which is equals to 2 cube is 8, then minus 4 into 2 square is 4 plus 5 into 2 plus 1. Now which is equals to 8 minus 4 4s are 16 plus 5 2s are 10 plus 1. 5 2s are 10. Sorry, here this is not plus 1. In the question it is minus 2. We're sorry, the question is given as minus 2. We copied as 1. So minus 2, minus 2, minus 2, and here minus 2. Minus 2. Now you observe 8 plus 10. 8 plus 10. 8 plus 10. 18. 18 minus. Now you see why I wrote minus. This is minus 16 and this is minus 2. So minus 16 minus 2 will give you minus 18. Minus 16 minus 2 will give you minus 18. So now next step, 18 minus 18 is equals to 0. That means we got p of 2 is equals to 0. That means 2 is the 0 of the polynomial. Therefore 2 is 0 of the given polynomial. 0 of the given polynomial. We got 2 as 0. Now we have to verify whether the given 1, this 1 is 0 of this cubic polynomial or not. Both the values are same. If 1 is 0 of the polynomial, then we need to verify the relationship between the zeros and the coefficient. Here x cube minus 4x square plus 5x minus 2. This is minus 2. Minus 2. Now we see whether 1 is 0 of the given polynomial or not. So substitute in place of x 1. P of 1 is equals to 1 cube minus 4 into 1 square plus 5 into 1 minus 2. Putting the value of x is equals to 1. Putting the value 1 in place of x, which is equals to 1 cube is 1, minus 4 into 1 square is 1 plus 5 into 1, 5 ones are 5 minus 2, which is equals to 1 minus 4 ones are 4. Here minus into plus minus, so 4 ones are 4 plus 5 minus 2 minus 2 minus 2. Now add the values. This is 1 plus 1 and plus 5. Together will give you 6. And minus 4 minus 2, that is minus 6. In class 6th or 7th we learned some or addition or subtraction of integers. Two negative integers when we add, we put the sign as a negative and add those two integers. 6 minus 6 will give you as 0. 6 minus 6 is equals to 0. That means this 1 also we got when we substitute, we are getting the answer as 0. Therefore, P of 1 is equals to 0 we got. Therefore, 1 is 0 of the given cubic polynomial. Observe it. Here 1 is the 0 of the given polynomial. Now we have 3 zeros actually. One is 2, another one is 1 that we substituted. Now we have one more 1. Even this also will give, because 1 and 1 both are equal. This also will be the 0. That means given values are zeros of the polynomial. Now we have to verify relationship between the zeros and the coefficients. Now we are verifying the relationship between the zeros and the coefficients of the given cubic polynomial. So the polynomial is x cube minus 4x square plus 5x minus 2, and we are assuming that let alpha is equals to 2, beta is equals to 1 and gamma is equals to 1. 3 zeros. 1 is alpha which is equal to 2, beta which is equals to 1 and gamma which is equals to 1. Now the coefficients of the given polynomial, the general form P of x, actually general form is what? The cubic polynomial ax cube plus bx square plus cx plus d. Now in this, write a is equals to, what is the value of a? If you don't have any number before the term, that is x or x cube or x square, that indicates as 1. If you don't have any term before the x cube or x square anywhere, that indicates 1. So x cube coefficient is 1. That means a is equals to 1. Next, b is equals to, including the sign you have to write. So b is equals to minus 4. Then c is equals to 5. And d is equals to minus 2. You observe this? A is equals to, the coefficients we are taking. A is equals to 1. B is equals to minus 4. C is equals to plus 5. That is plus, no need to write. Then d is equals to minus 2. Now alpha is equals to 2, beta is equals to 1 and gamma is equals to 1. Verifying the relationship between the zeros and the coefficients. Verifying the relationship between the zeros and the coefficients of the given polynomial. That is, now sum of the zeros. First one is alpha plus beta plus gamma. Alpha plus beta plus gamma, which is a formula, that is minus b by a. Minus b by a, the coefficient of x square by the coefficient of x cube. So which can be alpha plus beta plus gamma. What is alpha? 2, beta is 1 and gamma is 1. So 2 plus 1 plus 1. 2 plus 1 plus 1, you will be obtaining 2 plus 1 3, 3 plus 1 4, which is equals to, now this should be equal to the coefficient of b, x square, the minus b. So minus b value, which is, here you have minus is for the formula and b value is minus 4. So minus of minus 4. This is 4. Minus of minus 4 by a value, the coefficient of a is 1, which is equals to, now you see minus into minus plus. minus into minus plus 4. 4 by 1 is nothing but 4. So alpha plus beta plus gamma, which is equals to minus b by a. Now alpha into beta into gamma, that is product of the zeros. Alpha into beta into gamma, which is equals to alpha into beta into gamma, which is equals to minus d by a. Observe it, minus d by a. Alpha is 2, beta is 1 and gamma is 1. So alpha into beta into gamma, 2 into 1 into 1. 2 ones are 2, 2 ones are 2. That means the answer is 2, which is equals to minus d. So here minus d in this given polynomial, that is a constant term. D is a constant. So minus of minus 2. This minus is from the formula and this minus 2 is the constant term by the value of a, which is equals to minus into minus, that is plus. Minus into minus is plus. So 2 by 1, which is nothing but 2. So we verified alpha plus beta plus gamma, alpha into beta into gamma. Now third one is there, alpha into beta plus beta into gamma plus gamma into alpha, which is equals to c by a. That we have to verify. Now alpha into beta plus beta into gamma plus gamma into alpha. So alpha into beta plus beta into gamma plus gamma into alpha, which is equals to c by a. See, product, sum of the products of zeros taken 2 at a time. Sum of the zeros, product 2 at a time. We are taking 2 at a time. So alpha into beta plus beta into gamma plus gamma into alpha. We are multiplying then adding. So we are taking 2 at a time. Alpha into beta. Alpha value is 2. 2 into 1 plus beta into gamma. Beta is 1 and gamma is also 1. So 1 into 1 plus gamma into alpha. Gamma is 1 and alpha is 2. So 1 into 2, which is equals to 2 ones are 2 plus 1 ones are 1 plus 1 twos are 2. So together 2 plus 1 3, 3 plus 2 5. So we got alpha into beta plus beta into gamma plus gamma into alpha is equals to 5. Now we see the coefficients c by a. Observe the value of c. What do we have? C value, c is equals to 5. 5 by the a value, that is the coefficient of x cube, 5 by 1, which is equals to, you are obtaining the value is 5. Therefore, so alpha plus beta plus gamma we got, and alpha into beta into gamma we got, alpha into beta plus beta into gamma plus gamma into alpha, that also we got. Therefore it is verified. What we verified? The relationship between the zeros and the coefficients of the given cubic polynomial. Do you understand how to verify the relationship between the zeros and the coefficients of the given cubic polynomial? Now we see the division algorithm for polynomial. Division algorithm for the polynomials. That is, two polynomials we take. Let us p of x and g of x. Two polynomials, p of x and g of x. If you divide g of x with p of x, then we obtain q of x as a quotient and r of x as the remainder. R of x as the remainder. R of x is nothing but remainder. Q of x is nothing but quotient. P of x is the dividend and g of x is the divisor. So now, if p of x and g of x are any two polynomials, p of x and q of x are any two polynomials, then with polynomials with g of x is not equal to 0, the divisor is not equal to 0, then we can find a polynomial q of x and r of x, quotient and remainder, such that p of x is equals to q of x, g of x into q of x, g of x into q of x plus r of x. So p of x can be written as, which is equals to g of x into q of x plus r of x, where r of x is equals to 0, the remainder may be, sometimes we may obtain 0, or the degree of remainder, that is r of x, is less than the degree of g of x. So degree of r of x is less than degree of g of x. So remainder r of x less than g of x. Now this can be written as, which you are learning from class 4th or 5th onwards, the division rule. Dividend is equals to, the dividend is equals to, so in class 4th and 5th we learned, that was the 4th and 5th division rule. Dividend is equals to divisor dividend is equals to divisor into quotient, divisor into quotient divisor into quotient plus remainder. Dividend is equals to divisor into quotient plus remainder. Suppose here we spoke g of x is not equal to 0, that means divisor should not be equal to 0. Then r of x is equal to 0, or degree of r of x is less than degree of g of x. R of x 0, remainder can be 0, or the degree of the remainder will be less than the degree of the divisor g of x. Now divisor into quotient plus remainder. If the remainder becomes 0, then it will be, which will be, g of x will be the factor of p of x. If the remainder is 0, then g of x will be the factor of p of x. So when we are saying it is a factor, that means definitely that which the divisor must be factor of the dividend. If the remainder is 0, then the divisor must be the factor of the dividend. That we see here. If alpha, in terms of algebraic terms, if alpha is the 0 of the polynomial p of x, if alpha is, here we see, if alpha is the 0 of p of x. What is p of x? Polynomial in variable x. If alpha is the 0 of p of x, then x minus alpha, that's what we learned in class 9th. If a is 0 of the polynomial, then x minus a is a factor. If b is 0 of the polynomial, x minus b is the factor of the polynomial p of x. So here in class 9th we learned, if alpha is the 0 of p of x means polynomial in variable x, then x minus alpha is a factor of, x minus alpha is a factor of p of x. If alpha is the 0 of p of x, then x minus alpha is a factor of p of x. Factor means the remainder must be 0. Factor must means when we are dividing, if we say 2x minus 2 is a factor of some polynomial, that means if you divide with x minus 2 that polynomial, then the remainder you must obtain as 0. So if alpha is 0 of the p of x, then x minus alpha is a factor of p of x. That means remainder must be 0. Now we verify with one example the division algorithm. Suppose verify whether it is a factor or not. That means you have to obtain remainder as 0. Verify means remainder may or may not be 0. If they say it is a factor, some any term x minus 2 or x minus 3 or x square minus 2 is a factor of some polynomial. That means you have to obtain the remainder exactly equal to 0. Now we see one example from exercise 2.3. in question number 1. From question number 1, divide polynomial p of x by polynomial g of x. So we are dividing the polynomial p of x with the polynomial g of x and find the remainder and quotient. We have to find the quotient and remainder. So here polynomial p of x is x to the power 4 minus 3x square plus 4x plus 5 and g of x is equals to x square plus 1 minus x. So whenever you start a division, first you have to see whether the powers of the variables are in order or not. Powers of the variables are in a particular order, either in a particular order. Particular order means here x power 4 is there, next x square is there. So in between x power 4 and x square, there is one term is missing, that is x cube. That is x cube. So identify the missing term. Then x square, then x, then constant. Here x square is there, then x is at last, then constant is 1. So rearrange the terms so that you can do the division in exact way, in appropriate way, to do in a correct way. Even if you arrange the terms in order, like x power 4, x cube is not there. For that you can write 0 into x cube. 0 into anything is 0 only. So we are adding a term 0 into x cube while dividing, and g of x we are rearranging first x square, then minus x, then plus 1. You see here solution, that is first, so normal long division, we know long division, that is divisor x square minus x, I am writing as first minus x, then plus 1. This is, now look at this, x to the power 4, next minus 3x square is there, but x cube term is missing. If you write x cube term as 0 into x cube, that will be easy for us to do the division. So plus, you write plus 0 into x cube, 0 into x cube, then 0 into x cube is nothing but 0 only. Then you write minus 3x square plus 4x plus 5. Suppose here even 4x is missing, then you have to write 0 into x. 0 into x. See the first highest power, then you continue. You see which powers are missing. For that you can write as 0 into. Next. Now to obtain here x to the power 4, we required a term. You have to multiply. So division in class 9th also you learn this division. Division in class 8th also learn factorization. So similar way, factorization and cancellation. So similar way we do the division to obtain the quotient over here. Here x power 2 is there and this is x power 4. So to get x power 4 here, we multiply this x square with x square. So here rough work, I am doing rough work over here. X square into this whole term, this is the divisor. So x square into x square minus x plus 1, if you multiply x square into x square, x to the power 4 minus x square into x, x cube, x square into 1, that is plus x square. So these terms you are going to write in this place now. X to the power 4 minus x cube plus x square. Now as we know division time, we subtract. While subtracting, so we need to check, because minus, subtraction is nothing but minus. We change the sign, this becomes minus, then plus, then this is minus. This is minus. Now plus x to the power 4 minus x to the power 4 gets cancelled. This is 0 and we have plus. So 0 is nothing but 0 only. So plus, see the down sign, x cube, it has plus sign. After changing the sign, x cube, then this is minus x square, this is minus 3x square. Minus 3 and minus 1 together is minus 4x square. Minus 4x square. Now bring down the term plus 4x. bring down the term plus 4x then plus 5 plus 4x plus 5. Now x square over, you see the first term here what you have, this is x cube, here you have x cube, what sign it has, plus sign, put the plus sign over here, x cube, and here you have x square, x cube x square. To obtain x cube you have to multiply this with x, so we are writing here x. Now x into this complete divisor, x into the divisor, so x into x square minus x plus 1, x into x square minus x plus 1, x into x square x cube, then plus into minus, minus x into x square, x into 1, that is x. So x cube minus x square plus x cube minus x square plus x. Subtraction. So signs, this will become plus, this will become minus. Now plus x cube minus x cube, both gets cancelled. Then minus 4 plus x, 4x square and plus x square, this is minus 4, this is plus 1, minus 4 plus 1 will give you minus 3x square, minus 4 plus 1 will give you minus 3x square. Then this is plus and this is minus, 4x minus 1x, observe it, plus 4x minus 1x will give you plus 3x, and then plus 5, bring down this plus 5 here. Now you have sign over here minus, so you have to multiply with minus, and this is 3x square. The sign first immediately write down here, the first term whatever will have, the same sign you have to write. So minus 3x square, we have x square in this place, and minus 3, so we need term minus 3. Minus 3 into x square minus x plus 1, we are multiplying. So minus 3 into x square is minus 3x square, minus 3 into x square is minus 3x square, minus into minus plus 3 into x plus 3x, then minus 3 into plus 1 will give you minus 3, 3 ones are 3. Now subtraction, this will become plus, this will become minus, now this will become plus. So minus 3x square plus 3x square cancel, plus 3x and minus 3x cancel, you have the remainder plus 5 plus 3 together is 8. So the remainder we obtained here is 8. While dividing you have to check the signs very carefully, while subtraction you have to check the signs very carefully. So now the remainder you obtained as 8. Remainder is 8, and this is the quotient. So therefore quotient is equals to, therefore statement, therefore quotient is equals to, that is x square minus x plus 1, x square minus x plus 1 is the quotient, and remainder is 8. Quotient is x square minus x plus 1, it's not plus 1, it's minus 3, x square minus x square plus x minus 3, x square plus x minus 3. Quotient is x square plus x minus 3 is the quotient, and the remainder is 8. The remainder is 8. This is how we do the division. Suppose in this time, while dividing, if you obtain the remainder 0, then this will be the factor. This will be the factor. I hope you understood how to do the division. Here we have some homework questions from exercise 2.3. I hope you understood how to divide with g of x and p of x. So p of x is the dividend, g of x is the divisor. Here divide the polynomial p of x by the polynomial g of x and find the quotient and the remainder in each of the following. So p of x is equals to x cube minus 3x square plus 5x minus 3. G of x is equals to x square minus 2. you see that whether the powers are in a particular order or not. Here in this g of x square is there, then 2 is there. X square. This is x square. So x square is there. X is missing. So that x there you can write as 0 into x. There you can write as 0 into x for the divisor. Now third question. P of x is equals to x to the power 4 minus 5x plus 6, which is equals to, and g of x is equals to 2 minus x square. Here x power 4 is given. Now x cube is not there. X square is also not there. So those two places you can write as 0 into x cube and 0 into x square plus 0 into x cube plus 0 into x square. And here g of x is equals to 2 minus x square. So first you rearrange the term. Minus x square should come first, plus 0 into x is not there, 0 into x plus 2. Rearrange the terms wherever it is possible, necessary. There you rearrange and add the terms where the term is missing. If its cube term is missing, 0 into x cube. If square term is missing, 0 into x square. So this is p of x and this is g of x. Divide, find the quotient and the remainder. I hope you understood how to divide. Now we see in the next class if it is a factor, whether the given term is a factor or not. Factor means the remainder must be 0. If not, remainder will not be 0. Thank you.